In this video, we will be teaching basic definite integrals by using the fundamental theorem of calculus and u-substitution. A definite integral is a way of calculating the area of certain regions in a plane. The fundamental theorem of calculus allows definite integrals to be computed in terms of indefinite integrals. The theorem is stated as the interval from a to b of f of x d of x equals f of b minus f of a. Now for a basic example. Here we have the integral from 1 to 3 of x squared plus 4x minus 7 dx. We will start out by taking the antiderivative of each of the terms, giving us 1/3 x cubed plus 2x squared minus 7x. And then next we want to find f of b and f of a. To do this, we will plug in 1 for f of a and 3 for f of b. Let's start with 3. Plugging in 3 to each of these x's, we get 1/3 times 27 plus 2 times 9 minus 7 times 3. All minus, then we plug in 1 for each of the x's, and we get 1/3 plus 2 minus 7. Combining these, we get 9 plus 18 minus 21, all minus 1/3 plus 2 minus 7. Going further, we get 6 minus negative 14 thirds, and then we find a common denominator and get 18 over 3 plus 14 over 3, which equals 32 over 3 for our final answer.
To take this a step further, we will use u-substitution. When dealing with u-substitution, one inputs a series of terms into the integral using the variable u. Here's our first example on the integral 0 to 1. As you see, it's raised to the third power, and it's quite difficult to do without using u-substitution. So we pull out what's in the parentheses and put u equals x squared plus 1. We take the derivative, the antiderivative, and we get, just the derivative, we get du equals 2x dx, which equals 1/2 du equals x dx. And with that 1/2, we put it on the outside of the integral 1/2. Now, we were from 0 to 1, and when you do u-substitution, these are going to change. So what we do is we plug in the 0 and 1 into our u. So we do u equals 0 squared plus 1, and u equals 1 squared plus 1. We end up getting 1 and 2, u to the third d of u. We take the antiderivative, and we get u to the fourth times the 1/2 and times the 1/4 from the antiderivative on the integral 1 to 2. This is going to give us 1/8 with u to the fourth still on the integral 1 to 2. Now let's take this a step further, and we have 1/8 times 2 to the fourth minus 1 to the fourth. This gives us 1/8, 16 minus 1, and our final answer is 15 over 8. Simple u-substitution.